Hi everyone, it's Miss Berry. In today's video, we are wrapping up chapter 4, which was like an introduction to probability. And we are wrapping up chapter 4 with section 4.4, which is called combinations and permutations. Now, I don't want to make the video super long. I think we can keep this one kind of short, but I just want to give you a quick introduction and motivation to why we would want to do this. So combinations and permutations are all about making choices. It's all about counting up how many choices that you have. And so whenever we are calculating probabilities and we have to make choices or make selections, the way that we make those choices can affect how we calculate the probability. And so what we're going to do today is we're going to think about how we can sort of categorize making choices. And then once we have a general idea of those categories, we can talk about how the probability calculation is affected by those categories. All right, hopefully that made sense. I've tried to record this video like 3 times, so I feel like I've already said this several times now. All right, so I'm going to share my screen with you. The reason that I'm recording with the screen recorder today is because we are going to be using the calculator. So make sure that you have your calculator out, and we'll get started. Right. Okay. There we go. All right, so hopefully you're seeing my PowerPoint right now. I'm going to turn my camera off so you don't have to stare at me the whole time. Okay. Then we'll get that down. Perfect. Okay. Hold on just a second. It's not letting me see the right screen. Oh, there it is. Perfect. Okay. All right. So hopefully we're all on the right page now. So talking about combinations and permutations. The first thing that we need to talk about are called factorials. Factorials have a special symbol. Let me show you that special symbol. All right, so the symbol for a factorial looks like an exclamation point. You might see an expression with a factorial written like this, so maybe like 5 factorial. All right, and so let's look at the definition and then I'll show you what 5 factorial means. It says a factorial is a product, meaning multiplication, of all of the positive integers less than or equal to that number. So it's going to be the product of all positive integers less than or equal to, in this case, 5. All right, so you start with that given number, and then you keep going down by 1. So you're going to do 5 times 4 times 3 times 2 times 1. 1 is the last positive integer, so you always stop with 1. All right, and then you can just multiply this out. So 5 factorial, again, is just a really shorthand way. 5 factorial is just a really shorthand way of writing this really long expression. So it really does, save us a lot of writing by using this symbol. All right, so if we multiply these, let's see, 5 times 4 is 20. And then times 3, 20 times 3 would be 60. Times 2 would be 120. Times 1, still 120. All right, so 5 factorial would be 120. All right, now we can do that by hand, but if you get a really big number, say like 15 factorial, that would be a lot to write out and multiply out, right? So that'd be like 15 times 14 times 13 times 12, all the way down to times 2 times 1. All right, so we have a little factorial function in our calculator, so I'm going to show you how to get to that. All right, so let's see. I can scoot this calculator over there. All right. So here is our calculator. If you're calculating, let's do 15 factorial. So 15, you're going to start by typing in the number. All right, so start by typing in the number. And then you're going to hit the math button, which is over here on the left-hand side of the calculator. It's the fourth button from the top in that first column. So it's right beneath the alpha button. All right, so there's the math button. Then you're going to scoot over here to probability. Prob stands for probability. All right, so that's all of our calculator functions related to probabilities. And then you can see the factorial button is right there. It's option number 4. So you scroll down to option number 4 and then just hit enter. So really big number. This means 1.307674368 e to the e12 means take the decimal and move it 12 places to the right. So this is 1, 2, 3, 4, 5, 6, 7. Oh, well, gosh, I lost count. 3, 6, 7, 8, 9. So that's 9. So then we would have 3 zeros after that. So that's a huge number. All right, so let's write down that answer. Gosh, I've lost my. Let me grab an old calculator. Okay, there we go. Now I got it. Goodness, I don't know how I'm going to fit this on here. All right, so 13076743668. We said that was 9 decimal places, so we need 3 more zeros to make it 12. So this is a huge number, right? I mean, we can't even wrap our brains around. That's 1 trillion, right? That would be billion, trillion. Yeah, that's 1,307,674,368,000. It's 15 factorial. All right, so the numbers get really big really fast. Okay, so factorials allow us to represent these really long expressions really in a really short way. So very useful little symbol. All right, so let's talk about what a combination is versus what a permutation is. If you're looking in the calculator, the functions for combinations of permutations are on the same screen as where we found the factorial. So we're going to be going to the same area of the calculator here. All right, so whenever you're asked to find a combination, that's where you are selecting items from a larger set, but the order does not matter. So the order in which you select the items does not matter. All right, so a good example of this would be like if you're picking out an outfit. It doesn't matter if you pick out your shirt first or your pants first, right? So it doesn't matter the order in which you select your outfit, right? So a permutation is very similar. It's still a selection of items from a larger set, but here for a permutation, the order does matter. All right, so a good example of this would be like whenever, say that we're looking at a certain event in the Olympics, and we're trying to bet on who's going to get first, second, and third place. All right, so the order then in which you choose those does matter because the person who gets first place is going to be, they get a different prize, right? They get a gold medal versus a person that gets second place who gets a silver medal versus a person that gets third place, which is a bronze medal. So the order of those items or people does matter. All right, so for our symbols, for combinations, we have this symbol NCR. If we're reading this out loud, that means N, choose, R. All right, so let me write that down. If we're reading this out loud, we would say N, choose, R. So what does that mean? That means N is the total number of items. So total number of items. Maybe that's like the number of shirts that you have in your closet. And then R is how many of those shirts are you going to choose? So that's going to be how many items you want to choose. So N is like the total R is how many you want to choose. N is typically the bigger of the two numbers, although they could be the same. You could say, I have 10 shirts to choose from, and I want to wear all 10 shirts today. All right, so again, the order in which you put those shirts on would not necessarily matter. Okay, for permutations, very similar symbol. It's just going to be NPR. All right, so NPR is the symbol there. And then if I'm reading this out loud, I'm sure there's different people read this different ways. But I say N permutate R. All right, so again, same thing here. N is the total number of items. R is the number of items that you want to choose. Okay. So if we're doing the Olympics example, maybe like whenever they start, maybe there's, I don't know, 30 people that are in the that have made it to the Olympics. In the end, there's going to be 3 people on the podium, so it would be like N permutate 3, or excuse me, 30 permutate 3. Right, so N is the total number of items. R is how many items that you're choosing. All right, so I've got a couple more examples for you. If either of those examples did not really resonate with you, I've got a few more here. All right, so for combinations, another example is choosing 2 toppings out of 10. So I was thinking here, like when you're ordering a pizza from Domino's or something, and you're just going to choose 2 toppings for your pizza. It doesn't matter if you click pepperoni first or, olives first, right? So you're going to get the same pizza either way. So choosing 2 toppings out of 10 available options for your pizza. If we were to write this in terms of our little symbol up here, we would say 10, choose 2. So 10 toppings total to choose from, and I'm going to choose 2 of those toppings. All right, and then the second example I came up with was selecting 3 faculty members from a group of 15 for a college-wide committee. So maybe you have 15 people in a department, and then out of those 15 people, you got to choose 3 to be on a particular committee. It doesn't matter if you choose Dr. Renren or Dr. Lugo or Dr. Yeager first. It doesn't matter what the order in which you choose those faculty members. They're all going to the same committee, right? So it's not like the first person that gets chosen has to be the president, and the second person that gets chosen has to be the vice president, right? So of the committee, right? So or the chairs, I guess is what we call them here. So like the first person you choose has to be the chair. Second person has to be the secretary. So the order in which you choose them does not matter. They're all 3 just going to be on the committee. All right, so for permutations, I had 2 little sports examples here. Those were the ones that I thought resonated the most with me. The first is permutations. The first example for permutations is choosing the batting order for a baseball team. So I was thinking like maybe you have, you'll have to forgive me, I don't know the numbers, but let's just say that you have 20 people on a baseball team, and every time they go up to bat, maybe 10 of them are gonna bat, right? So the order matters, right? So the order in which you're choosing these players to go up to bat matters, right? So that's why we're doing permutations instead of combinations. And then we would say we have 20 players in total. We've got to select 10 of them to go bat this inning. So that would be 20 permutate 10. And then the second example is the same one that I mentioned before, the top 3 runners in a race that had 16 runners. So maybe like you're going to Las Vegas and you're going to bet on this. So you would say, okay, well, I can figure out how many options there are for the top 3 by calculating 16 permutate 3. So that would tell me the total number of options that were possible for the top 3. Right, so all of these combinations, permutation, they're just counting up the number of ways that you could make that choice. All right, so if I do 10, let me switch to my little laser. If I calculate 10, choose 2, that's going to tell me all of the different combinations of 2 topping pizzas that I could have come up with. And then if I do 15, choose 3, That's all of the different groups of 3 faculty members that I could have selected for that committee out of my 15 choices. And then 20 permutate 10, that's going to tell me all the different combinations of 10 players that I could choose for my batting order. And then 16 permutate 3, that's going to tell me all the top 3, all the possible top 3s for this race. All right, so let's practice doing some evaluating of these expressions that involve combinations and permutations. And as we're practicing plugging in this first little factorial, I'll show you where the button is for combinations and permutations. All right, so our first task is that we have to evaluate the expression 6 factorial. You could totally do this by hand, right? You could do 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. But I'm going to show you how to do it on the calculator. All right, so let me grab the calculator, put it on, there it is, okay. So 6 factorial, I'm pressing the 6 button, then I'm going to the math button over here on the left-hand side of the screen. Fourth one from the top on your calculator. Right, then I'm scrolling over to probability, and you can see that my factorial is option number 4. And then notice that option 2 is the permutation, and then option 3 is the combination. All right, so they're all right there together. All right, so I'm going down to option 4, and 6 factorial is 720. So 6 factorial is 720. All right, so next we have a little bit of a more complicated expression. This time we are calculating factorials, still calculating factorials. This time there's 2 factorials, and one of them is in the numerator and one of them is in the denominator. Don't let that mess you up. You're just plugging this straight into the calculator. All right, so grab your calculator, and we're going to do 12. Then go to your factorial button. So math, over to probability, option 4, divided by. So all I did was press the divided by button, nothing fancy there. Right, and so it was divided by 8 factorial. So I typed in 8, then hitting the math button, over to probability, and option 4. All right, and then hit enter, and there we go, 11,880. So 12 factorial over 8 factorial. Oh, I also showed you this. I had this like already typed into my PowerPoint. If you wanted to do it one at a time, so 12 factorial by itself is this really big number, and then 8 factorial is 40,320, and then you can just divide those manually. So if you don't want to plug it all in at one time like I just showed you, you are welcome to do it that way as well. So doing like 12 factorial and then 8 factorial, and then just dividing those. You can do that as well. You get the same answer. Okay, so let's look at our next problem. All right, evaluate the expression. Now we're getting even more complicated. All right, so 11 factorial over 4 factorial times 11 minus 4 factorial. I like to go ahead and simplify what's inside the parentheses. You don't technically have to, but I like to go in here and just say, okay, well, oops, sorry, I don't know what was going on with my pen there. Let me try that again. Okay, well, I know that 11 minus 4 is 7. So I like to do that first. Although you could totally just plug it in like that if you wanted to. All right, so here's what we're trying to calculate. 11 factorial over 4 factorial times 7 factorial. Don't try to do anything crazy here. Just plug it in the calculator. All right, so 11 factorial, we know that that would be 11 times 10 times 9 times 8 times 7 times 6 times, all the way to 1. But let's just find 11 factorial. Now, this one I would suggest doing in 2 chunks. I'll show you why in just a second. All right, so that's the numerator. All right, so that's the numerator. If you want to plug this all in at one time, you have to put parentheses around the bottom. So you can do that all at one time. You just have to put parentheses around. You have to remember to put parentheses around the bottom. All right, so that was the numerator. Let's see, that's 39,916,800. And then for the denominator, you're just doing nothing fancy here. 4 factorial, 7 factorial. You don't even need to put the multiplication button. Or, yeah, we don't even need to hit the little multiplication symbol in between it. Your calculator's going to know that you're multiplying those. All right, so 4 factorial times 7 factorial is 120,960. So 120,960. All right, and then if you divide those, let's divide those. 399,16800 divided by 120,960 is 330. Okay, so now we have done some practice with factorial. So now I'm assuming that you feel pretty comfortable using the factorial function in your calculator. Now we're going to move on to practicing using the combination and permutation buttons in the calculator, and then we'll do a couple word problems. All right. Okay. Practicing with the permutation button in the calculator. We have 9 permutate 3. Oh, shoot. Sorry, I didn't mean to put the answer up there yet. Okay, let's grab the calculator. 9 permutate 3. Okay, let me clear out this screen. We got a lot going on here. Clear that up. Okay. 9 permutate 3. Going to start by plugging in the 9. Just hit 9. All right, then I'm going to go to the math button. I'm going to go over to probability again. And then I'm going to select option number 2. This time that's NPR or in permutate R. All right, you see that it put the little 9 in front of the P for me. And then I have 3. 9 permutate 3. All right, so you just go over there, type in 3, hit enter. So 9 permutate 3 is 504. If you were thinking about this in terms of like, what does this number mean? This is saying like, if I was trying to choose 3 items from a set of 9 and the order mattered. Okay, so I'm trying to choose 3 items from a set of 9 and the order mattered. All right, and then let's go back to our PowerPoint. All right. 9 permutate. I think I had a C in there originally. 9 permutate 3 is 504. All right, so if I was trying to choose 3 items from a set of 9 and the order mattered, then I would have 504 possible choices. All right, so next we have 11 choose 4. All right, so let's grab our calculator. 11 choose 4. You're going to start by typing in 11. Go to the math button. Go over to probability. In choose R is option 3, NCR. All right, so 11 choose 4. So I just went over there, typed in 4, hit enter, 330. All right, so if you're making 11 choices, or excuse me, you have 11 items total and you want to choose 4 of them, and the order doesn't matter, then there are 330 possible choices. All right, so 11 choose 4 is 330. All right, so let's look at a word problem. All right, so this one says a doctor visits her patients during morning rounds. In how many ways can the doctor visit 9 patients during her morning rounds? Do you think that the order matters here? Does the order in which she visits her patients matter? I don't think so. I don't think that the order matters here, but this one is kind of a trick question because you don't really need to use this is actually something that we've done before. We've talked about how do we figure out what the sample size is, how many outcomes are in this sample space, and this is the same thing. It says, how many ways can the doctor visit her 9 patients during her morning rounds? Well, that just means that we're making 9 choices, right? So the way that we've done this in the past is we would draw like a little box for each choice. Sorry, we would draw a little box for each choice. We would say, okay, we have to make 9 choices here. So this is going to be the first person that I go see. This is going to be the second person I go see, or this doctor goes and sees. I've got 9 people altogether. Okay. So whenever I go see this first patient, how many options do I have for which patient I can go see when I'm making my first visit? I have 9 patients I can go see, right? Well, then I've already seen that first patient. So now I only have 8 patients left to see. Then I have 7 patients left to see. Then 6, then 5, then 4, 3, 2, and then 1. All right, so this is just our fundamental principle of counting. All right, so this is our fundamental principle of counting. And what we've created here is 9 factorial. All right, so 9 factorial. And let's go plug in 9 factorial to our calculator. 9 factorial be 362,880. So she has, let's see, the question said, how many ways can she visit her patients? 9 factorial is 362,880. So she has 362,880 ways that she could visit her patients. So she could go to patient A first, then patient B, then C. So she could, let's say she could go in alphabetical order. Then she could go, patient C first, then patient A, then B, then D, then E, and so on. All right, so there are 362,880 ways that she could go visit her patients. All right, and then our last one is the one that we're going to be using. We're going to have to decide if we're going to do a combination or permutation on. It says, suppose that your boss is going to be choosing 3 employees in your office to attend a conference in Jamaica. Because all 15 of you want to go, he decides that the only fair way is to draw names out of a hat. And it says, what is the probability that you, Stephanie, and Joe are chosen? So maybe this is like you and your work friends, and you all want to go on the trip together. We're going to figure out what's the probability that y'all get to go. And we're supposed to write our answer as a fraction or round it to 4 decimal places. All right, so I just came up with like 15 names here for, let's just say this is all of the employees, just to think about like the choices that we're making here. So what we would like to happen is that you, Stephanie, and Joe get to go on the trip. But there's a lot of other things that could happen, right? Like maybe you, Stephanie, and Amy get to go. Or maybe you, Stephanie, and Nia get to go. Or you, Stephanie, and Nikki. Or maybe Stephanie doesn't get to go at all. And maybe you, Amy, and Nia go. Or maybe you don't get to go at all. And maybe Amy, Nia, and Ash get to go. All right, so there are lots of different options for who could go on this trip. So we're going to decide, okay, when we're making these selections, and that's how I think that's a good way to determine, like, do I have to use the permutator combinations here, permutations or combinations here, or is this just a factorial problem? Because that was something that I was thinking about as we were going through that doctor's doctor visiting her patients, like how do you know when you need to use it? It's always going to be that you have a total number of items that you have to choose from, and then you have a smaller number that you're wanting to choose. So for the doctor problem, they weren't saying like how many options does she have for the first two people that she's going to go see. It was just asking just in total how many options does she have for ways that she can visit her patients. Here you have a total number of items that you're choosing from, all 15 of the employees, and you have to choose a smaller number of those that actually get to, in this case, go on the trip. All right, so let's think about this. Do you think that the order in which you choose the employees matters? Does it matter if you choose Stephanie first, or if you choose Joe first, or if you choose you first? Right. Do you think that matters? No, you're all going to get to go on the trip. It's not like the first person that gets chosen gets first class and the second person that gets chosen gets business class. All right. So the order doesn't matter. Whoever gets chosen first is going on the trip, and the person that gets chosen third goes on the trip. So the order that you choose the employees does not matter. Since the order does not matter, we're going to use the combination function instead of the permutation function. All right, so we're going to be doing in choose R. Okay. All right. Sorry, I just saw that something was on the screen that wasn't supposed to be there yet, so I had to fix that real quick. Okay, I fixed it. Okay. Ignore this part down here for right now. All right, so now that we know that we're going to be using the in choose R function, we know that it's going to be 15 choose 3. 15 choose 3. All right, so 15 choose 3 is the same thing as 15 big C little 3. All right, so let's type this in our calculator. All right, I'm going to clear out my screen. Type in 15 first. Go to the math button. Go over to probability. And then choose option number 3. 15 choose 3. All right, so there are 455 possible groups that could get to go on the trip. All right, so there are 455 possible groups that could go on the trip. That's like when we were talking about it could be you, Stephanie, and Joe. It could be you, Stephanie, and Nia. It could be Stephanie, Joe, and Nia. So there's 455 different groups that might get to go on the trip. Since the order that inside of that group, the order that you choose, the people that are getting to go does not matter. There's only one way that you can successfully get you, Stephanie, and Joe on the trip. So the probability of getting you, Stephanie, and Joe on the trip is going to be success over total. There's only one way to get y'all all three on the trip. There's 455 different groups to choose from. All right, so 1 out of 455. And if you were writing that as a decimal, that would be 0.0022. Okay, so that was everything for this section. If you have any questions, let me know. And we are totally done for chapter 4, and the next video you'll be starting is chapter 5. All right, so I'll see y'all next time.